Hello and welcome to the Math Critique, where I take topics you might be struggling with and show you that you can do it because you already have. Today's topics will be focusing on graphs of exponential functions. Let's dive in. So, because we want to take a look at this and think about this in terms of things that you've already done, let's start off by talking about what you've already done and do a little bit of a refresher. So this is very much like when you've learned how to graph y equals x squared and learned how to use transformations with y equals x squared. Okay, so the steps in this were you first drew a table to find out what the shape looks like, and then you looked at the transformations to figure out if you go up, down, left, right, stretch, skew, all of those sorts of things. Okay, so let's see what this looked like the first time you did it. We're going to start off with y equals x squared. Okay, now we have the table here with y equals x squared. The table you'd build out the table by starting off just by plugging in numbers for x and figuring out what each of the y's are. So that's what we're going to do here. Okay, so I'm going to start off with x equals -3. And so I take that x equals -3 and I plug it in right up here into this x squared. Okay, so -3 squared is just 9. I can take -2 and I can plug -2 in for x also. And if I plug -2 in for x, -2 squared is 4. Same thing with -1. Plug in -1, I get 1. Plug in 0, you get 0. Plug in 1, you get 1. 2, plug in 2, you get 4. And plug in 3, you get 9. These are all things that you've done before. All you're doing is plugging numbers in. And then the next thing you did is you plotted each of these points. Now, I'm using a graph that's a little too small, so I'm not going to bother with x equals -3 and x equals 9. I'm just going to jump right to -2, -1, 0, 1, and 2. So I plot each of those points on the graph, and then I draw my line. So that's basically what the shape looks like. Okay, so that's how we started off learning what x squared looks like. And then we said, how do we get the graph to change when we change the equation? And let's say we change the equation to y equals x squared plus 3. Now, when you first started working on this, you looked at y equals x squared plus 3, and you probably plugged it into a table to figure out how the transformation was, and then once you figured out the transformation, you didn't bother with the table anymore. All you did is you said, okay, well, since that plus 3 is being added to the end after the x squared, you're just going to go up 3 units, and you're going to redraw the graph. It just moves up 3. Okay? What would happen if I have x plus 3 in parentheses, and that's squared? Well, since it's inside the parentheses with the x, that means I'm going to move it left or right, and it's going to be in the opposite direction. And again, you probably did this just by tables at first, but then you figured out, okay, if it's inside with the x, I'm going to move in the opposite direction that many units. So here, I'm going to move left 3 units, because the right is the positive direction, so left is the negative. You go the opposite direction, so your graph is going to look something like this. Okay. Last but not least, what if I had negative x squared? If I have that negative sitting out in front of the x squared, that means I'm going to flip this graph over the x-axis. So that means this graph, flip over the x-axis. So I'm going to take this graph, it's going to flip over the x, just like that. That's what the negative does. And again, you probably started this off with the table and plotting all the points with the table, but then you figure out, okay, if it's sitting in front of the x there, it's going to flip over the x-axis. So let's do the same exact thing, but now we're going to use 2 to the x. Okay, so I'm going to use the same set of numbers. If I start off with -3 for x, I plug in -3, 2 raised to the -3rd power. Now remember, when you have something that you're raising to the negative exponent, what that does is that flips the graph, the number over. So this ends up being 2 to the negative 3 is the same as 1 over 2 to the third. Or you might have seen it as 2, 1/2. You might have seen it this way too. It's all the same. It doesn't matter. 1/2 to the third. Either way, the number you end up with there is 1 over 8. Okay, so you can do the same thing. I'm going to go ahead and get rid of all of this here because all of this is getting in the way now. So I can do this exact same thing using -2. I can take -2 and I plug -2 in. If I plug -2 in, I get 2 to the negative 2, which is the same as 1 over 2 squared, which is the same as 1 over 4. Do the same thing with -1. Plug -1 in, you get 1/2. So I'm going to go through the rest of these pretty quick here. You plug in 0. Anything to the 0 power is 1, except for 0, but we're not worried about that right now. 1, plug in 1, 2 to the first is 2. Plug in 2, 2 squared is 4. Plug in 3, 3 to the third, 2 to the third is 8. So we're going to go ahead and we'll plot all the points. Now, again, my graph isn't quite big enough for the 0.38, but I'll plot the rest of the points. I get -3, -1/8, and then -2, 1/4, and then I can keep plotting all of these points, and then I draw my line. So all of my exponential graphs are going to have this general shape. It's going to start pretty low, right about the x-axis, and it's going to rise up from there. Now, there's something that's kind of cool that happens with exponential functions, is as I keep going to the left, as I keep going in that direction, I plug in -4, -5, -6. What you notice is the numbers that we have for y are going to keep getting smaller, but they're never going to hit 0, and they're never going to go past 0. So what that does is that creates something called an asymptote. An asymptote just means it's an imaginary line that the graph cannot cross, cannot be at that point. So this graph is going to get closer and closer and closer to this asymptote, but it'll never touch the asymptote. In this case, the asymptote is 0, because the graph is going to get, as you get smaller and smaller numbers, as x gets more and more negative, the asymptote, the number as a whole, the y-coordinate, is going to get smaller and smaller and smaller, but never actually going to hit 0. So I'm going to ask the same questions I did on the last problem when we had x squared. So now that I know the basic shape, how did the graph change when we changed the equation to y equals 2 to the x plus 3? Well, here's the cool thing about this is, again, just like I said at the beginning, you already know how to do this because you've already done this. When you add something to the end, just like we did here, that plus 3, it's sitting outside after the x squared, or after the 2 to the x, that means we're going to move it up that many units. So I'm going to start off just to kind of give myself a starting point. I'm going to take that asymptote and I'm going to move it up 3 units. So here is my new asymptote. And the asymptote's usually a dashed line just to say that we know it's not going to be part of the graph. It's just an imaginary line that we're getting closer to. Now, for the graph itself, everything else is going to be exactly the same. The whole thing is just shifted up by the 3 units. So it comes up like this, and then it raises exactly the same way. Okay, what if I have that plus 3 sitting in the exponent now with the x? Well, just like with the x squared, when I had x plus 3 quantity squared, that was with the x. So that means I'm going to move either left or right It's going to be the opposite direction and whatever that number is. So that number is plus 3. So that means all of these points are going to be moving to the left 3 units. Okay, so I have that 1/8 is down here, down at -3, so that means that -6 is now my new 1/8. I'm not going to worry about moving the asymptote because I'm not moving up or down at all. Okay, so all of these points are going to be about the same, just shifted over 3 units. So here are all of our points, and I'm going to draw the line going through all of the points. It's the exact same graph, just shifted over left 3 units. Okay, so what if I have a negative in front of the base? I do the same thing that I did when I had a negative in front of the x squared in the last problem. So what that means is I'm going to, instead of now flipping over the so what I'll do is instead of it being above the x-axis, I'm going to flip it over. It's going to go below the x-axis. So now the graph is going to be down here. It's going to be a mirror image that goes down instead of up. But everything else stays the same. Okay, so that's what the transformations are. Those are some of the basic transformations. So the question that everyone asks is, where does this get difficult then? And it really doesn't. There is one thing that you got to do that's a little different, but one of the big things to remember when it comes to all of this is it's not that it's more difficult, there's just another step. What if the base is a fraction instead of the base being a whole number? Well, that's actually going to be, again, it's going to sound like it's going to make it more difficult. It's really not, because we know that fraction as a base is the same as if we had a negative exponent. So what I'm going to do is I'm going to change that from 1/2 to the x. I'm going to make that 2 to the negative x. Okay, now on the last problem we saw, when we had a negative in front of the 2, so when there was the negative sitting out here, we flipped it over the x-axis. When the negative is sitting up here, we flip it over the y-axis. Okay, so I'm going to get rid of this negative there because that doesn't matter anymore. And what I'm going to do is I'm going to take my basic shape. Here is what the basic graph looks like. And what I'm going to do is, since the negative is now in front of the x, I'm going to flip it over the y-axis. Sorry, there's my asymptote. Flip it over the y-axis, and now I have the exact same graph, just flipped over the y. So now here's the cool thing, is that this actually makes a lot of sense when you think about it in terms of the graph. Okay? And you can look at this either way. If you look at, with this problem up at the top, 1/2 to the x. If you look at that and you say, plug in numbers, as you plug in numbers for x that are getting bigger and bigger, the number as a whole is going to get smaller and smaller. 1/2, if I plug in 1 for x, that's 1/2 to the first, which is 1/2. If I plug in 2 for x, I get 1/4. If I plug in 3 for x, I get 1/8. The numbers are getting smaller and smaller as x gets bigger and bigger. And you can do the exact same thing with the other problem here, with the changed problem, and you're going to get the same numbers. So 2 to the negative x. So it's going to be going down as you get as your x's get larger and larger. So what's the difference between fractions and whole numbers? You can look at it two ways. You can either say, okay, if it's a fraction under the as the base is between 0 and 1. If it's a fraction there, that means that exponent is gonna make it flip over the y-axis. That fraction will make it flip over the y-axis, a better way to say that. So instead of it increasing, it's going to be decreasing. So let's look at one other way that this looks like it's supposed to get difficult, and it's really not. Let's say instead of 1/2, or instead of a base 2, we have 1/3. Okay, so what's the big difference here? Just like with the last problem, I'm going to change that from 1/3 to the x. I'm going to make that x to the 3 to the negative x. Just makes it a little easier to see, because now I know that I'm going to take the original graph, I'm going to flip it over the y-axis. Now, the part that usually trips people up is, since this is now a 3, how is that going to change the graph? The only way that's going to change the graph is it's going to make it steeper. It's going to make it grow quicker. Okay, so basically, if this was y equals 3 to the x, it would look like this. If you look at this graph, you can see pretty easily when x, you can plug in a number when x is, let me write out the problem here. So this would be like y equals 3 to the x. So when x is 0, y is 1. When x is 1, y is 3. And you can plug in numbers and see how the graph just grows a lot quicker. Since I have x 3 to the negative x, that's going to just flip that over the y-axis, and it'll look like that. So exact same problem. If the base is bigger, it's going to be steeper. That's the only difference. Nothing really huge. And also, don't forget about your asymptote. Okay, so last problem. Let's put all this together. Now I have y equals 1/3 x plus 2 minus 5. Okay, so the first thing I want to do is, again, I want to change that base to a negative exponent. Okay, I have that, and then I'm going to try to figure out what the transformations are telling me. Okay, I can start this off either way, doesn't matter. I know because I have this 3 here, that means it's going to be a little steeper than the x squared, or I'm sorry, 2 to the x. That negative in front of the exponent means I'm going to flip it over the y-axis. This plus 2 means I'm going to move it to the left 2. And then that minus 5 means I'm going to drop it down 5. So let's go ahead and get just my y equals 3 to the x graph up. Just my standard graph and my asymptote. So because I'm moving this down, I'm going to go ahead and start off by moving the asymptote down 5. And then I'm going to drop that graph exactly the same way, except I'm going to flip it over the y-axis. Okay, so that took care of. It's steep. It's much steeper. You have the minus 5. We moved it down 5. We have the negative. Switch the direction. The only thing we haven't done yet is the plus 2, which means we got to take this and move it to the left 2 units. And there's your graph. So just take it one step at a time. I usually start off with a vertical, the vertical shift to make it a little easier, and then just graph it one piece at a time.